Hello, everyone. Today, I will be speaking to you about a smart irrigation mobile app for corn, cotton, peanut, and soybean. This is a project funded by the USDA National Institute of Food and Agriculture. I'm a professor at the University of Georgia in the Crop and Soil Sciences Department. As you can see, my name is George Vellidis. I am an agricultural engineer by training, and my area of interest is precision agriculture and specifically precision irrigation. And this project fits neatly under that domain. The CropFit app is a truly disruptive smart irrigation app that we believe will offer intelligent management to growers who grow the primary economic crops of the southeastern United States. And I'll describe this app in detail as we go through the presentation. The fundamental of the app is that we will be incorporating existing smart irrigation apps that have been developed over the past few years by my research team and colleagues at the University of Florida. So specifically in the CropFit app, what we'll be doing is we'll be incorporating the existing apps for cotton, soybean, and corn, and we will be developing a new one for peanut, which I'll explain in a few minutes. These apps are all available publicly for both Android and iOS platforms. If you would like to take a look at them, you can go to smartirrigationapps.org and find links to each one of these. Or you can go to the app stores and search for smart irrigation apps, all one word. So the specific goals of this proposal and project were to incorporate the existing corn, cotton, and soybean apps into one app, to develop a new peanut app that will be part of the suite. Now, this peanut app will have its foundation on the existing Irrigator Pro model. The Irrigator Pro model is an irrigation scheduling tool that was developed by the U.S. Department of Agriculture over the past 30 years or so. It's a very sound tool, but it requires sensor inputs that make it a little bit cumbersome for some growers to use. But it's extensively used by crop consultants in Georgia and other states in the United States. So it's a very, very sound model that we're going to convert into a model that works similar to the corn, cotton, and soybean apps. And I'll explain how those models work in a few minutes. We will evaluate and incorporate new features that will customize the CropFit app for individual fields. And then we'll conduct stakeholder engagement and social science research. This is important because there is some hesitancy among American growers to adopt irrigation scheduling tools that are based on the technology that I'll describe here. They are much more comfortable installing soil moisture sensors because they can physically see the sensor, and they can see sort of on an hourly basis the response of the sensor in their field. Now, why do we want to pursue this project? To justify why we're going to do this, I'm going to show you a couple of slides of the performance of the cotton smart irrigation app that we've had publicly available for the past 5 years, just to show you that it is a powerful tool and performs quite well. On the next slide, I'm going to show you some comparison data to this irrigation scheduling tool, which is what our extension service has been recommending to Georgia farmers for the past many years. And this is a checkbook method that relies on calculated daily crop water use from historical data and is designed to make sure that water is not a limiting factor. In other words, I think it provides a little more water than is necessary during weeks when we have cooler weather or overcast skies. So this table here shows you the performance of the Smart Irrigation Cotton app to the compared to the checkbook method. So here on the second column, you can see the yield response of the app in pounds per acres, but it's very similar in terms of kilograms per hectare. In the third column, you see the yield difference. So a positive sign here means that the cotton app outperformed the method that our extension service recommends to growers by 10 to 20% in most years. So we have a positive yield response by using the Smart Irrigation app. And just as importantly, we see that in every year we have a significant reduction in water use. So a negative sign indicates that the cotton app used less water than the checkbook method. And this seems to hold true regardless of the kind of season we have. But the strength in these tools is that they are actually using current weather conditions, as I'll explain. So they adjust the crop's daily water use based on environmental parameters. And so they more accurately reflect what the crop is using on a daily basis. And so to get into the science behind these tools a little bit, it's very simple. It's the FAO 56 method that has been published by the Food and Agricultural Organization of the United Nations now for decades. Essentially what we do is we use this equation here where ETO is Penman Monteith, or theoretical evapotranspiration. We multiply that by a crop coefficient, and from that we estimate the daily crop water use. But if you want to look at this in a more simple way, imagine that this blue box here is a planter on your terrace or your balcony. You've got it filled with water. You water it in the morning, so there's no deficit of water for the plant. And then what we do is we estimate the daily crop water use of the plant, and then we add any rain and irrigation. And then so we keep a balance of how much water is available in the soil by subtracting evapotranspiration from the available water, adding rain and irrigation. And as we move, if we don't get rain or irrigation for several days, the soil will dry. And it's typically accepted that when you reach 50% of plant available water, it's recommended that you irrigate. So in our apps, we send notifications to the users when we approach these thresholds, and it's time to irrigate. And if you let it go too far, you're getting into very dry conditions where you might be inducing some stress on the crop. Now, driving information for developing these kind of tools is always good meteorological data. And I think this is how this presentation fits into the theme of the area we're discussing today, is that we're encompassing the visual tools that are available to us today to create really accurate irrigation scheduling models. And so what you see here is that I'm going to show you 3 or 4 slides that show you what kind of weather data we're able to pull into these apps. So we have many sources available to us. One of I think the most reliable sources is to use weather station networks. So in the United States, some states have very robust weather station networks that are typically maintained by a university, a public university in the state. So you can see in Florida, there are some 50 stations that are maintained by the University of Florida. In Georgia, there are 87 maintained by the University of Georgia. Many stations in Oklahoma maintained by Oklahoma State University. And similarly in Arizona, maintained by the University of Arizona. So so the apps can pull data from these weather station networks if they exist, if they're close to the field where the cotton or the other crops are being grown. And from these, we pull precipitation, temperature data, and other data that we use to calculate evapotranspiration. But we recognize that in many places, fields will not be close to a weather station, so we have other options built in. If you're not close to a weather station, you can select that your data source comes from these gridded maps that are available. We currently use a company called Dark Sky, and you can use your coordinates to pull data from a 4-kilometer grid that includes your field. And from that, you get an estimate of precipitation, temperature. And the U.S. National Weather Service also offers an estimate of theoretical evapotranspiration that can be used in the continental United States. This is not available worldwide or in other parts of the United States, just in the continental United States. But this tool is available globally, and so it can be used from anywhere. So the most critical weather parameter really is accurate precipitation information. And so we've built into our app the ability to pull weather data from automated rain gauges that are available from private companies. And at the moment, we have 4 built in. A local company in Georgia called Trellis, an Austrian company called Pesci, and 2 American companies called Davis and Onset. Onset is a company that makes very popular hobo equipment. So if you have one of these and you install it in your field and have a subscription, our apps are able to go to the API of each of these companies and pull the rain from your field and import it directly into the app. And honestly, I don't recommend that anyone use these apps for serious irrigation scheduling unless they have accurate precipitation data. So it could also be inputted by hand from just a plastic rain gauge that goes on a fence post. There's nothing wrong with that. It just takes a little bit of additional effort. So the other fundamental piece is this crop coefficient curve. And there's one innovation here that I think makes this particular tool, these particular tools that we have developed a little bit better than others, is that instead of using days after planting to drive the changes in the crop coefficient, we actually use accumulated heat units, which better predict the phenological stages of the plant. And so you can see here that for the cotton example, as we go through these different phenological stages, the crop coefficient changes. And it's quite high when we are in the middle of the reproductive phase, which is, for most crops, the most important time to make sure that you don't have any water stress in the crop. So we have developed these curves for all the crops that are part of our suite. We field tested them extensively, and we feel that they perform well in the environment in which we have tested them. One of the challenges, of course, is what happens if someone wants to use the cotton app in Brazil or in Australia? How does the crop coefficient curve perform there for those conditions? So that's something that we're working on. We're adding different crop coefficient curves for different regions in the United States at the moment. And if at some point we have funding or we can do this globally, we'll pursue that as well. So, for example, right now we are working with colleagues in Arizona and Missouri and Oklahoma and several other states to make sure that the crop coefficient curve we're using represents their conditions well. So let me now take a few minutes to show you how these apps actually perform, how you use them, and then we'll talk about the new developments we're building in for the CropFit app. So again, I'm going to use the Cotton app as an example. Once you initiate the app, you can create a new field, register a new field by hitting the little plus sign. Here's an example of a screenshot where several fields have already been installed. The little blue bars I'll explain in detail later, but these indicate the status of the field. So you don't even have to actually look at each individual field to understand whether you're in deficit and need to irrigate or not. But let's start from the beginning. So this is the way apps currently work. We have made many modifications as part of this project that I'll show you as we go through. But this is the current status, and it's not the final product that will result as the outcome of this project. So when you start out, essentially the phone GPS determines the pin of your location. You can use a map or a satellite image, and then you can zoom in, zoom out, and drop the pin on your field. Then you name the field, you enter the planting date, and we built these apps so that they can pull the weather data retroactively. So even if you are 2, 3, 4 weeks late in initiating the app, that's fine as long as you can enter the irrigation information. All the other stuff will be generated automatically. Then it gives you the options of the weather stations that are nearby you, and it literally looks for the closest one. So even if it's 1,000 kilometers away, it'll tell you 1,000 kilometers away. If it's that far away, it's probably not a good choice for your weather data. But in this case, here's one that's close by, so you could select that. But if you're far away, then you can select this national weather data grid, and then you use your coordinates to pick out data from the grid. We also have the option of selecting the soil moisture sensors that I mentioned before. Right now, in this screenshot, I only have 3 of the 4 rain gauges that we support, but there are 4. So essentially what we do is we get you to log into your account that belongs to the rain gauge. And we don't keep that information, it's just pass-through information. And then you select the sensor, and then from that point on, the data from that particular sensor, we've got multiple of them deployed, stream to the app, and that's how your precipitation data are recorded. It overrides any other data that might be coming in for precipitation. The next step is to select the soil water holding capacity of your soil type. This is important for creating a soil water balance, of course. So we have some 7 default soil types with some default values here. If you know what your soil type is that, and you have actual data for it, you can modify it right here. You can actually enter the correct value. Now I'll explain some innovation we're doing for the CropFit app that improves this in a few minutes. You select the type of irrigation system that you might have, and this is important because this determines the efficiency, so the percent of water that leaves the irrigation system that makes it to the soil. And of course, you can adjust that as well. If you have a default irrigation rate, this is the amount of water you would normally apply. You can add it here. That saves you the effort of actually typing in the number later. And then this is sort of a crucial part here. This is when the app will send you notifications about the condition of your soil and prompt you to act. So we have some default values for the different crops based on the phenology, but that can be adjusted as well. And here are several screenshots showing the notifications that you get. So unless you get a notification that tells you action is needed, you really never have to open the apps. You just look at the notifications. So for example, here's one saying that you've exceeded the threshold that you've set and irrigation is recommended. You can see several indicating rain. So if you click on this and you open the app and you can see the homestead field here, and the 42% deficit then is reflected right here in this little bar. You can see that. If you were going to irrigate, you could add irrigation by pressing this button and the default irrigation amount is added. If you put on a different amount, you press see details and then you can adjust the amount you irrigated. Also, you get notifications when there's rain observed, so you can correct that if that is not correct. And then you also get notifications about the phenology. So down at the bottom of this main user screen, you keep track of the phenology. And it's important to make sure that, once in a while you visit the field to check and make sure that the app is accurately predicting the stage of your crop. Some of the new improvements related to the project is that we've added a weather forecast feature so that you can look forward to determine whether you are expecting rain and so on, so you can make a decision about irrigation. We're building in a feature that allows us to tell you when the next expected irrigation event would be based on the weather forecast. And then if you click on this top right-hand button, you can download a CSV of everything that's happened in the field from planting until today. Most growers are not going to be interested in this information, but it's important to growers who are getting funding to do water conservation. That way they can document their actions and provide this to the agency that's been providing the funding. Additional new features is that you can go back when you press this view all button, you can go back and edit every single day. So if you've forgotten to record an irrigation event, or you wanted to check when your crop actually transitioned from one stage to another, you can go back and observe what happened every single day. And you can make adjustments, of course, as necessary. So some of the new features that we're building into the CropFit app that don't exist into the old apps. So for example, once you open the CropFit app, you'll be able to select different crops. So you can have fields registered for different crops. These fields will stay in memory. And so if you've got corn in this field this year and next year you're planting peanut in it, then you will have all the field information. You just have to update the crop and the planting date. We will also allow our users to now delineate their fields. And this will allow us to pull the soil data from the USDA NRCS Surgo database so that we have a better accurate description of soil water holding capacity. So you still have the 7 soil types here, but it also gives you what the NRCS estimate is of that soil type, so the grower can have more information. We're also going to build in the ability to use NDVI data of this area to take a look at what the biomass level is on the field, and perhaps adjust the conditions of individual fields, just the crop coefficient curve of individual fields, rather than having a theoretical crop coefficient curve. So all these things are now being tested and evaluated. And we hope that by next year, we will be in the field evaluating these things with growers, these improvements with growers, and evaluating, their interest in these kinds of tools and promoting their engagement. And then finally, we expect to release the CropFit app for public use sometime in late 2023, after we've tested it for a couple of field seasons. So it'll be used, publicly available for all growers in early 2024. And with that, I'd like to close. I have my contact information here. If anybody would like to text me or email me, my phone number is right to the WhatsApp and Viber apps, as well as Messenger, so you can send me a message in many different ways. I thank you for your attention and for the invitation to participate.